it should be okay to do that.
Testing. Is this better for remote people? Okay, let's go. We're at Thursday now. You should potentially be familiar with the Notewell if you've been attending all week, but we might have some new people in town just for today because we're so special. So if you're not familiar with the Notewell, please do familiarize yourself. This contains a whole bunch of stuff about your participation at the IETF, including things like code of conduct, our anti-harassment procedures, how your contributions in this room and in other drafts kind of work with the IETF world, and rules around IP, art, and patents and participation and stuff like that. This stuff's important. There's a lot of information there. If you're not familiar, take some time now to take a quick look before you participate. We have some basic meeting tips here. We want in-person participation to be run by the on-site Meet Echo tool. So if you've not yet done so, there's a QR code just on the far side of the room where you can check in. And then if you would like to participate in the discussion, enter yourself in the queue via that tool, and we'll run that queue and get you in and out. Same for the remote participants. Using this tool makes it good to participate whether you're remote or local. And we appreciate those from all people. So the caveat there is, please, we have a mask policy for this IETF. Familiarize yourself with that if you've not yet done so as well. This requires you to wear a mask at all times in the room unless you are actively speaking or brief periods where you're eating or drinking. So please do that because we'll enforce it. Remote participants, it's the usual, if you can wear headphones, that helps a lot for the quality of the audio. But I think we're pretty familiar with how Meet Echo is working these days. Some of the administrivia, we do need a note taker before we get into the meaty parts of this. Do we have any volunteers for that, please? Okay, Robin's kindly volunteered to take some notes, but Robin's remote. And as a remote participant who's tried that in the past, it is difficult. Do we have anyone who would volunteer to help Robin, who's in the room? All you need to do is jump on the link there to the Hedge doc and edit away. Mamoka, could I ask you, please? Yeah, thank you very much. I just want to make sure we reflect the notes. That's good. That's it. Yes, we have an agenda. We've done our updates. We've taken our 5 minutes already, but I'm going to blame Meet Echo. We have some working group items we want to go through: multipath, acknowledgement frequency, and the QLog specifications. And then we're going to get into some other items. We called it the reliable quick stream resets there. That might be a different title, but it's the same kind of concept. So we'll see exciting developments there. And then a presentation from some research on quick handshakes and some of the challenges that we've got there. So would anyone like to bash that agenda while we have the chance? I'm not seeing anyone. Don't see anything in the chat. Nope. So without more ado, some brief updates since the last meeting. We have the quick version negotiation and quick v2 drafts have entered Auth48 status. So we're just waiting for a few boxes to be checked, and then we should expect those to be published as RFCs, which is an exciting time. And the remaining things this week, Quick is now becoming a foundation for various other activities that are going on in the IETF. There's been a few sessions like web transport, etc., and mask. But the remaining ones this week, in case you're not familiar, with Media over Quick, where there's 2 sessions. Thursday today, just the one right after lunch, and Friday tomorrow. So if you're not familiar with those, it might be something else that you're interested in. And that's all we have. So could we get the presenters for multipath up, please?
Eat the mic.
I will eat the mic from now on. Oops, that's the wrong thing there. Stop.
Okay. Hello everyone, I'm Yanmei from Alibaba. Today, Yunfei and I will introduce the updates of multi-pass quick extension. Next slide, please. There are several modifications from the version 3 to version 4. The first and the most important modification is that we remove the use of a single packet number space on multiple passes as a fully supported option. And by the way, as a conclusion drawn from the last IETF meeting, we have a vote. And by the way, as the single packet number space was barely to support the zero length connection ID used in multiple passes. So we also remove the pass identifier and the pass identifier type, as we do not need to support that anymore. And we also remove the packet number space ID. And these three modifications are associated with each other. Please feel free to check the details on the GitHub. And we also clarify the pass usage for pass abandon frame. And we add some additional passes and explanation for packet number spaces and connection IDs used for passes. And also we update some scheduling guidance. These modifications are in the URL below, and please feel free to check it. Next slide, please. The most important thing is that we remove the pass. I think the previous page.
Sorry.
Yeah, and the most important thing that we remove the use of single packet number space in this version. It's a conclusion we draw from the last IETF meeting. We have a vote, if people remember. And the single packet number space is for the support to use zero length connection ID in multiple passes. So we also remove the pass identifiers, and we also require that people must use non-zero connection IDs in both connections when we use a multi-pass extension. And also we update the IAM table for enable multi-pass transport parameter. Currently version we have a very long parameter, but we will get a shorter one before we make the last call. And we have two technical reports. The first one, we have made a large-scale experiments for comparing the experience between the single packet number space and the multiple packet number space. And also, Quinty has support another report for the compare with these two single packet number space and the multiple packet number space. And we both draw a conclusion that multiple packet number space had a better experience in most cases. So please feel free to check these reports. Next slide, please. Okay, by the way, as we have removed the support of zero length connection ID use in multiple passes, we also removed the pass identifier and the pass identifier type to support it. And we also have some other issues which are discussed in the mail list and in the GitHub. The first one is to attempt to use a connection pass, constant connection pass ID, as if the CID changes and the pass ID remain unchanged. But in our current version, we just use the sequence number of connection ID to define the pass identifier of each pass. So we will have more discussion on the next page. I will let Yunfei for the discussion.
Hi, thanks, Yanmei. This is Yunfei from Alibaba. And what Yanmei has just told you is the things we have done for the version number 4 during the last couple of months. And right now, I'm going to cover a lot of issues that the authors are debating, and we have lots of discussion on the GitHub, and we would like to solicit more feedback from the working group. I think the first issue is the biggest one. So right now in the current draft, we remove the pass identifier, and we only use DCID sequence number for identification purpose. And for this issue, we have a lot of discussion on the GitHub. And if you're interested, you can look at the GitHub. For some of the discussion, we have more than 54 replies. I believe I remember the name correct. So there are lots of opinion exchanged. But in short, what do we want to decide is whether to have a stable pass ID versus a loose pass ID model. By stable pass ID, I mean that you have a constant pass identifier during the lifetime of a pass. For example, when you open the first pass, the second pass, and third pass, and you assign each pass a constant identifier, and this identifier will not change even if the full tuple changes. And by loose pass ID model, I mean to only use the DCID sequence number for identification purpose. And that sequence number can change if your full tuple changes. So the benefit of using a stable pass ID is that it really simplifies your mental model for the designer, as it is quite straightforward and intuitive to understand. But the issue is that when you try to do the implementation, and you find that, okay, the full tuple is volatile because due to reasons like net rebinding, the full tuple can change. And as a consequence, what you need to do is you need to differentiate what is net rebinding, genuine path migration, and opening a new path. So usually, detecting net rebinding is not hard because you still use the old DCID, the connection ID, to communicate. It's just the full tuple changes. But there are some corner cases like, what if your CID rotation and net rebinding happen at the same time? And to detect these corner cases is not quite straightforward. And for the loose path ID model, we only use DCID sequence number, and we do not speak path ID anymore. It turns out that the DCID sequence number is quite fundamental because it enables you to do almost everything, including path creation, path status update, path closing, and also the DCID sequence number is fundamentally linked to the packet number space and is used to generate the nonce for encryption in the multipath. So the benefit of using the loose path ID model is that you will have no problems in handling net rebinding, path migration, and opening a new path. And you will also, there is also no ambiguity when the packet number space changes. But the disadvantage of using a loose path ID model is that the path is not stable and it may not be intuitive at the first glance. So yeah, we would like to hear the opinions from the audience and the working group on this issue. So anybody in the queue?
Sorry, my phone is slow. I couldn't get in the queue. But Alessandro Ghedini, Cloudflare. I think this change makes sense from like a specification point of view. For implementations, we'll still need some kind of ID, and using the connection ID sequence number also makes sense. I don't know specifically about the implementation, whether this change actually improves anything or not, but implementing it should not be that complicated. So it's fine by me, I think.
Kazuho, so I think my weak preference goes to loose path ID model. Regarding the stable path ID model, I kind of wonder if I mean, stacks can have that concept if they want. People can have that concept if they want. But I'm not sure if we have to expose that stable path ID as a concept in the protocol design.
Mia Kuhlmann. I just wanted to add that actually, I think the loose model was in the draft before. It was just like a few places where it wasn't like really clear, or like it didn't explain it as clearly. But like spelling it out did help us to make a lot of decisions about the protocol mechanisms itself. And then the other point that you made is like, yes, in your implementation, you might still have this kind of stable path identifier, but then it's just really an implementation detail. And so for us, it's really important. There have been a bunch of questions where we had to decide about how to address a question, how to like when to open a new path or close a new path or when to see a new path, and having this model really helps us to clarify that. So that was the main purpose here.
Anyone else on this issue? No.
No more in the queue. Is this good feedback for you to be able to make progress as a team?
Okay. Okay.
Is the question?
What?
Have you got what you needed from this?
Yeah, I think so. I think so. Yeah.
Okay.
Yeah.
Good. Thank you.
Yeah. Next slide, please. The next issue is not as complicated as the first one. It's about the error code for missing a CID during the handshake. Because in the draft version number 4, we make a decision that we only keep multiple packet number space, and so that now if you want to use multipass, and you should not, you must not use zero-length CID. But what if you have an enable a multipass parameter set to 1 is received, and the carrying packet does not contain a non-zero length connection ID, and then you have a connection error. And then we need to decide what types of error there should be. Can we? So right now the authors think we could just use transport parameter error for this purpose. So does everybody agree on this issue? Marty.
I forget exactly how many error codes we have available to us that are unused just yet, but we have lots of them. Make a new one. This doesn't make any sense to me. And I think people will want to know that this is distinct from other sort of configuration things. I think transport parameter error is very generic, and there's no transport parameters involved in this process that you're describing. Well, apart from the, I guess you're saying that the multipath transport parameter is wrong.
Yeah.
Yeah.
Whereas, I don't know, isn't it the fact that the connection ID is zero length the wrong thing here?
Well, you can. Alessandro Ghedini, Cloudflare. You can have zero-line connection IDs, but you can't have zero-line connection IDs and enable multipath set to 1. So you shouldn't. I guess it's a matter of perspective. Like you shouldn't set the transport parameter if you have a zero-line connection ID, or you shouldn't use zero-line connection ID if you don't have a transport. Like either way, it's fine. Like it doesn't change that much. But as you said, like there's like a billions error code, so we can just create a new one.
I've just added myself to the queue. Speaking as an individual, I like error codes for this kind of thing with specific ones. People can always use the most generic error code if they really want, but there is a difference between a problem in the format of the container or the set of things that we have and actual, like a semantic problem in a bug that people are doing. And having a clear indicator of that can really help interop and those kinds of things. As an individual in opinion.
Mira?
Yeah, I have the feeling it doesn't make a big difference because we also, I think there's also kind of a, how's it called? Not comment field. You can put like additional information in the error code, right? So you could add something there. So I'm wondering if there's anything from an implementation point of view that you would like do differently if you get one or the other error, because that might be the main point.
I'll respond to that because I want to. That yeah, for some implementations, we will like actively discard the reason phrase because it is basically untrusted stuff. So and again, it's you can put anything in there. So interrupting and hoping that they're going to tell you that there was a problem or something. It's a code is simpler in my opinion.
Yeah, but I mean, at the end, it's an implementation error, and the connection breaks, and that's it, right? I mean, like, can you really do something else?
Yeah, I can call somebody and say what's going on. Something's changed recently. We're seeing some spike in some other thing, and yeah.
Okay, thanks.
I mean, from a operational perspective, it's easier to have metrics for connection errors than it is to have logs for connection error reasons. It's easier to aggregate, I guess.
Okay, so as chair, what I'm hearing is a strong sense in the room for defining a new error code, and we'll reflect that into the issue and ask people to review the PR as a form of consensus for that one. Thanks.
Okay, okay. Then yeah, we can move on to the next slide. Oh, the next issue is, so right now we have a path status frame. And because this is a base draft, at the beginning, we decided that we only want to keep it as simple as possible. So we only have two values. One is standby and one is available of the path. And the question is, do we want to add more alternative value into the path status frame? Yes, yeah, this is also the question for the working group. Do we see the need to do that?
I mean, is the question, do we want to add them now or in general in the future?
In the draft,
yeah, I don't think so,
okay.
But it might be fine to leave the option open to add more later.
Okay, okay, okay. Yeah.
So I think in this case, actually, the important question is the second one here. Like, what should you do if you get a value that you don't know about, right?
Yeah, I guess the question is if we add more later, should that be, we add the transport parameter and then the implementation that advertised that is required to do something with the new one, or an implementation can just send a new path status and then if you don't understand it, you just ignore it. It probably sort of depends on what the actual meaning of the path status would be. So I guess for now we can just say ignore it. And then, I mean, if later one actually need to be there would be a new draft defining a new path status, and that would say, oh, but this one, if you implement it, you need to know, you need to do the whole transport parameter thing, and if not, then you don't send it.
Question.
Yeah. Good afternoon. Yes, I mean, Miria said it very well. I mean, there is no point in defining the value to agree on what the behavior means for that value. And the way we do that in QUIC by using the extension mechanism. So what I would say is that if people want to have new value to say, I have a status that says pause this stream for 5 seconds. That's fine. Write an extension draft, says, get the acknowledgement that the other end understands it, and then you can use it. But if you see a new path status that comes out of the blue, that's a protocol error.
Martin.
Yeah, Martin Thompson. I heard a number of things that Alessandro said made me get up. There's a document the IB published a little while ago that talks about extensibility and extension points and whatnot. This is a really good case of you're building another extension point into the protocol and having a very clear understanding of what your expectations are for someone who receives the next value is super important. I have a suggestion. I'm going to suggest that you remove this extension point entirely and use 2 different frame types for the 2 different frame statuses. And so you would have path standby and path available, and then there would be no way to extend using this particular field. What you would have to do then is exactly what Christian was talking about, is if you wanted to do a new type of status, you would define a new frame and you would use the quick extensibility mechanisms. And then you don't have the problem that this extension point becomes rotten and unusable because people who implemented it only implemented the two values and implemented it as a Boolean, for instance, which is totally natural because path active, path not active is exactly what I would do in my implementation based on this. So you would find that people would have the code rotten. You try to ship the third value and it just wouldn't work. So I think you want two frames here.
Okay.
I would agree with both of those. Part of the design philosophy in QUIC, sorry, Mike Bishop. Part of the design philosophy for the core protocol was to make it impossible to send something invalid as often as possible. And here you're just asking to receive an invalid value when something develops in the future. Make it an extension where you can only send the frame after you've got acknowledged support for the new value.
Miri.
Yeah, I just want to agree, and I think that actually totally makes sense because it kind of reverses the mapping between path and status. So now we send a status frame and we actually announce the path within the frame, and that also means we can actually put multiple connection IDs in the frame, which is really nice. We can say all these paths should be on standby, and that totally makes sense to me.
Okay, yeah.
Yeah, so as I said, we don't actually have a use for new path statuses, so doing two frames is fine. I just want to point out is it's not that if you send, saying what Mike was saying, if you send a value that is not supported, it's not invalid, it's just not supported. What do I do with that? The same thing you do with unknown HTTP3 frame, for example.
Yeah, but we don't have that in QUIC, right? So that's kind of the problem. So
sure, that's fine.
So I think what we're hearing is that there's pretty strong support for splitting this into multiple frames, and that any new paths in the future would also probably use new frames.
Okay, sounds good. Yeah, I think we got the idea. Yeah. We can move to the next slide. Oh, the next slide is about the return path of multipath ACK. And right now, the current draft says that the ACK MP frame should be sent on the same path, but we do not block the possibility of sending it on any path. We just say some recommendation in the draft. The motivation behind this is to ease your RTT estimation, because in multipath, you have a scenario where, for example, if you allow ACK MP to return from any path, and for one sample, the RTT may be the add of one short path and one long path. And for another sample, the RTT value is the add of two short paths. And so what's end up happening is in your sample, you will have this discrete steps or jumps in your RTT estimation. And we believe that today's the RTT estimation module in the conjunct controller is not designed to cope with this scenario. And we're a bit afraid of causing some troubles in the conjunction controller, especially for those one who will use RTT estimates for the conjunct control purpose. And so the questions we want to ask the working group and the audience is that should we, in this draft, encourage the returning of ACK MP from any path? And if so, what would be the simple and most effective algorithm for the RTT estimation in this types of scenario? Christian.
I think that part of the issue is that we are trying to use a single RTT estimate to mean many things. You are mentioning using RTT estimates for error recovery, and you are using RTT estimate for congestion control. I think the complexity only happens if you rely on the RTT estimate for congestion control. if you only are concerned with past discovery, with loss discovery, knowing when something is not done, the only thing you need is to estimate an RTO, because effectively your loss discovery will be triggered then by the RAC algorithm, the insertion of new transmissions. So if you were to do the naive implementation, which is to say, whenever I receive an acknowledgement, I act the packets that is being acknowledged, and I use that in my RTO estimates for that path. What you will get is that you will incorporate in your statistics both the network status and the algorithmic implementation on the other side. And as long as your peer follows a predictable strategy, your RTO will reflect both the path evolution and the strategy used by the peer. And it will be perfectly fine to use it to trigger a PTO or something like that. It will just work. And I think that should be the best estimate. And we should say that if people want to do congestion estimate based on delays, they have to have a specification on how they do that.
Ian, you joined the queue.
Yes.
Ian Sweat. Yeah, I second Christian's comment that as long as it's consistent, everything should work out fine. There are a number of cases where internet paths are highly asymmetric, and yeah, it's not uncommon at all. But if it was unstable, that would actually start introducing some very interesting challenges. So I think, yeah, and in many ways, actually, if for some reason you have a faster, lower RTT one-way delay path to send the ACK on, why would you not, right? It's faster feedback. So.
Yeah, so just to be clear, I think we will still have a discussion in the draft about what the effects are, sending it here or there or whatever. But like the question is, should we remove the should here? That's the main question, and it sounds like people want to remove it. And then, or you can reply.
I think it's okay to remove the should on the same path, but I would keep a should for using a consistent path.
For what?
Using a consistent path.
I don't know, why does it have to be normative?
Because otherwise you're making the peer's job of like doing proper RTT estimation and PTO estimation and spurious retransmits and other things quite difficult.
Yeah, so I wanted to make another proposal. So the other way, and that's not what's currently used in QUIC, but the other way to get an estimate of the RTT would just send a ping frame. Is that something we could recommend instead? Like if you want to have stable RTTs, then you should actually initially use ping frames to get it on that path. It's just an idea.
Miria, we can discuss that further, but I think that Ian and I are pretty much in agreement there. This business of if you keep your strategy, your ACK strategy is relatively stable, what will happen occasionally is that you will have a breakup of your acknowledgement path that forces you to pick a new one. But that's very similar to what happens when you have a routing event in the network. And most PTO algorithms are designed to do that. I mean, basically, the only thing you risk is that your PTO will fire a little bit too soon, and you will get an acknowledgement of the PTO. So I think that encouraging consistency is good. And then we have to delay the other problem, which is if you do want to measure RTT because you are actually interested in measuring that path, then it's probably because you use that in a congestion control algorithm of some kind, and you have to explain how to do that in the congestion control algorithm specification.
Okay, that sounds right. It still doesn't clarify if we need any normative language or not for me.
I would agree with Jan. should be consistent, because if you sometimes send the acknowledgement after a tenth of a second and sometimes after 5/10 of a second, you're going to mess up the other guy. So if you choose an acknowledgement pass, you should try to keep that stable unless you have a very strong change in the conditions.
So I'm going to jump in here. It sounds like we're kind of arguing over whether the people agree on the problem, but whether it be normative language or not is a little bit up for debate, which I think it's not the most important part of this issue. But everyone agrees that there's an issue here, and maybe further discussion about what the recommendation should be, but maybe not having a should or should not sort of thing. So I think we can move on.
Yeah, we can open an issue and have more discussion later.
I just had one clarification question for Ian. You said use the same method, but is consistently using the same path to send the acknowledgements, or using sort of the same strategy? Because if you use the same path, like a path might just go away at some point, and then you have to pick another path to send the acknowledgements, and that changes things.
So, sorry, guys, we have other issues we need to look at.
Okay.
Can you guys take it offline? Thank you.
Oh, yeah. Let's move on to the next slide.
Yeah.
Oh, for the next slide, it's also a GitHub issue, but I think the title is a bit confusing. But we want to say here is that now we do not speak pass ID anymore. So the pass status is linked to the CID sequence number. And so if we update the CID and the CID change, do we want to also update the pass status explicitly, or we don't bother sending a new pass status as we assume the pass status is the same as before? And the second question is, should we also expand the pass status frame to hold information for multiple CIDs? I think we already got the answer. If we want to do that, we should do that in a separate frame. And the third thing is, also, do we want to define something that could hold information for future CIDs? The benefit of doing this is that when you know the CID, the pass status for the future CIDs, and when you want to rotate the CID, you can just pick the CID that has a pass status that is the same as the current pass. So that can save you from sending another pass status update. Yes, so for this question, any opinions from the audience?
Alessandro Gadini, Cloudflare. I think the path frame should hold information for multiple CIDs is what Miria was talking about earlier.
Yes.
I think, I don't know, like from an implementation perspective, that would be useful. Like sending multiple frames versus just I don't know if there are situations where we might actually want to update many paths at once, and then just sending multiple frames is probably just fine. So I'd rather keep it simple, probably.
Yeah, so your point is, anyway, the pass status is not sent as frequent, right? So
right.
you can just send multiple. Okay.
So the scenario is that you kind of changing your connection ID for whatever purpose, for privacy reasons, linkage reasons, or whatever, and you might do that on like all your passes, right? And so you have to change the connection ID, and then you also have to change a bunch of pass update states. It's like not a big issue, but it's like a small optimization. And like the other point is like you should probably, the situation where you actively change your connection ID is probably not happen very often and might have other consequences. So it's like, yeah, one or the other solution might be fine. I don't know. But I think from the model that we discussed earlier, I think there's actually no reason to not say in advance, like I provide you a bunch of connection IDs, and these connection IDs like can either be used like for a standby pass or for non-standby pass, and you can like define it in advance, even if the connection IDs are not in use yet. I don't see like a big issue about that, because it's really about just providing information about the semantics of a connection ID, independent of the question if it's in use yet or not. On the other hand, I think the only drawback is maybe that you're kind of restricting yourself about how you can use the connection IDs in future, and so you might need to provide a few more connection IDs or whatever.
Speak at the mic, please.
Like it sort of limits how you can use certain connection IDs, like you might change your mind later.
But you can send a new one.
Yeah. Well, unless there's like limits, and then.
But you set the limit.
True. Yeah.
So yeah. So I think in summary, both works, and we take it to the GitHub and have a little bit more discussion there, I guess.
Yeah, please visit GitHub and have more discussion there. And next slide, please. Okay, the final issues is do we want an explicit pass setup frame? The current draft, in the current draft, we use a mechanism from the QUIC-V1, the connection migration mechanism, to set up a new pass. And but there is another proposal, is that we try to have a separate pass setup frame. But the issue with this pass setup frame is that you need to somehow include a pass ID into the frame. But as we just discussed, the author already agreed to remove explicit pass ID in the current draft. And the separate pass setup also deviates the original design requirement to just align with the pass creation in RFC 9000. But we also acknowledge that there might be some benefits of using an explicit pass setup frame. For example, you can include some pass setup signal and pass parameters into the frame. Those parameters could be something like max ACK delay or max pass idle timeout or something else. Yeah, and so the decision we need to make here is whether or not do we want the pass setup and a separate pass setup frame. Any feedback for this one? Should we just keep it as in the current draft, or we want a separate pass setup frame?
Christian.
My advice would be to just leave that for. Is that some kind of echo now? My advice would be to just leave that for further extension. I mean, I really think that when we have something which is debated like that, we should leave it out of the draft and say if people want to have that, if they really want to have these kind of things you describe and of specifying a bunch of parameters, they should do an extension to QUIC and present a new frame to do that.
Yeah, I agree with Christian. Yeah.
Okay, yeah, it seems that we have a consensus here. Next slide, please. On the next setup, the first one is the registration for a transport parameter, frame types, and error codes. And then there are also many opening issues on the GitHub. So the authors want to finalize discussion on the remaining opening issues. And also, of course, more implementation experience is still desired. And right now, we, for my knowledge, I know that we have a couple of implementations, like Ericsson, Christian's have the implementation, and Cloudflare has implementation, and we also have an implementation at Alibaba. And I think right now we have already, for the multipass draft, we have already solved two major issues. One is to decide whether to use single packet number space or multiple packet number space. And the other one is about the pass ID. And I think after this, the protocol will become relatively stable, and maybe when those implementations are updated to the version number 4, we can start thinking about something interop testing. Yeah, that's it.
Thank you. Yeah, just to add to that, we're making good progress on this draft. We've kind of turned a corner, so to say. There's about 11 open issues. No, 20 open issues. Okay, so we need to make a bit more progress, but we've done that today, and yeah, that's good. So what as a chair, what I'm interested in is in trying to do kind of reawaken our hackathon interrupting adventures from the last couple of years ago. So that's something personally probably want to do, but if there's any other folks who are really interested in doing that at the next hackathon, I encourage people to coordinate and collaborate and do things like trying to define interrupt matrices and all of these kinds of things so we can just hit the ground running. So.
Yeah, and to add to that, I think especially for some of these issues like with the ACking and the RDT estimates, like that is something that could benefit from some of the interop testing we've done in the past with things like connection migration, sussing out issues both in implementation and the spec.
So I see Marcus jumped in the queue there. Did you have something to add?
Yeah, it's maybe not related to this thing about the hackathon, but a general comment. So there's an ongoing discussion in TSV WG on multipath. The main focus in this discussion is on concurrent path usage, which I think also highly affects the multipath QUIC. And the question is if this is experimental or proposed standard at the end. And I already shared this discussion with the QUIC working group on the mailing list. And I think it would be really good if the people who are engaged in multipath QUIC would also show up in this discussion to achieve a good consensus here.
Okay, thanks.
Just one more point. We will organize some interop tests after this meeting. So please feel free to join. And we really want more feedback from implementations.
Great. Thank you for your time, presenters. Ian, if you come on up.
Good morning. We're getting an update on ACK frequency, which has made a lot of progress since last IETF. Next slide. So this is just an overview of the frame format. This is pretty much what we talked about last time. We now have reordering threshold, which we discussed last time, and there's been a fair amount of work to actually make that pretty readable in the draft. Next slide. Okay, let's go over some resolved issues, and then we can go to the one remaining open issue. Okay. We discussed reordering threshold in London. We decided to change ignore order to reordering threshold. A number of PRs relating to it were merged. I hope now that it is reasonably clear what it is and how it works. There are also two examples to kind of make it clearer in case people want to walk through some examples. Please take a look at this if you have not already, and especially if you plan on implementing it, and ensure that the text is clear. Wonderful. Martin.
Yeah, just something stuck out on the last slide there. Reordering threshold is an 8-bit field. Why
Yes.
is that not a variant? I mean, it's not a big deal, right? But
I think we discussed this in London, and can someone remind me what we ended up with?
I don't remember. I was under the impression that we agreed to variant it because that's what we do in this working group. But I can't remember, honestly.
I mean, I want to set it to 1,000.
Can someone also check the draft to make sure I didn't copy paste it wrong and make sure it's not actually a variant, because I might have actually made it a variant and the slides might be wrong.
Okay, I'll check.
Okay, thank you. I'm fine with making it a variant if that's easy enough.
It's also an easier way to represent disabling it.
It is
by
a
setting
variant.
it to- Oh,
Thank you.
okay.
Yeah,
just forgot.
I think we decided to make it a variant last time, and then I just didn't change the slides.
It's a variant in our implementation too, so that would have been a little bit awkward if it.
Okay. All right, let's keep going. Next slide. Good bonus time. So a number of musts were changed to shoulds. This was mostly done to align better with how RFC 9000 talks about sending acknowledgements. There are a few to know. There are musts in RFC 9000, but it's mostly about what you should never do. Like you should never ACK and ACK only packet type stuff. There are very few musts about like when you have to send an acknowledgement. And I put two particularly like simple, but like, obvious examples into the slide here. A receiving endpoint should send at least one ACK frame when more than this number of ACK eliciting packets have been received. So again, this aligns with RFC 9000, where it says, a receiving endpoint should acknowledge every other ACK eliciting packet. Okay. Next slide. Yes. So there were some kind of spurious musts also about dealing with multiple ACK frequency frames. There also just generally there was an awful lot of text around this that seemed somewhat unnecessary, so it got minimized. So we kept the fact that the sequence number must be monotonically increasing, but we do not require it start at 0 because that didn't seem like an enforceable must, and it also is not necessary from a functional perspective. That is actually a change though. So if people have a strong opinion that really it absolutely has to start at 0, now would be a great time to speak up. Okay, next slide. There are a number of smaller changes. We actually added security considerations, so that's important, as well as IANA considerations. There was an unnecessary must about bursts. In general, there was a variety of text in the document that was pretty much duplicative of 9002, but not quite as well written. So we removed most of it and just kind of said, like, do the thing that 9002 says to do. This document doesn't change anything about bursts. There's some clarification about what the default reordering threshold actually is. We wrote the transport param code point because this is not backwards compatible. And I guess we removed yet another unnecessary must. Next slide. So let's go to the one open issue. So this is one ACK per RTT enough. So the current text says a sender should cause a receiver to send an acknowledgement at least once per RTT if there are unacknowledged ACK eliciting packets in flight. This is not so dissimilar from what is in RFC 9000, if I remember correctly. But in this particular case, obviously, this extension allows you a lot more leeway in terms of what you can do with acknowledgements, and so could be more of a foot gun if used improperly. I will also note that when min ACK delay, which is the minimum value that the peer will set an ACK delay to, is larger than RTT, say the timer granularity is 1 millisecond, and you have a 100 microsecond RTT, probably you're not going to get more than one ACK per RTT in a lot of circumstances. But let's assume that data center use cases are sort of out of scope of this discussion. So the issue proposes to change it to maybe 2, or maybe 3 or 4. There are a number of options. We could do nothing. We can change it to 2. We can drop the normative text entirely because really, obviously it's in the sender's best interest to get congestion feedback that is useful. We can add some recommended values, whether it's normative recommended or not recommended, or we can probably do something else. I believe one person decided, so this issue is opened by Gory. Kazuo commented and I think suggested the last option, which is to add some sort of recommendation around numbers like 3 or 4 tend to work well. I can't remember if Kazuo wanted that to be normative or kind of more just non-normative, but okay, let's open it. I think.
So
who's next?
Speaking as an individual, I think we shouldn't have really any normative language around this. I think having recommendations or color is okay, but anticipating all future use cases of when people should, like the data center thing you mentioned is I don't think it is necessarily out of scope because people could be doing this in microsecond networks and it may not always be reasonable to send ACKs, or I don't think we should really be anticipating all the use cases of ACKs. So I'd be mildly supportive of some color, saying like this is reasonable to do these kinds of things, but nothing normative because there's no point. The whole point of this extension is to open up flexibility in acting.
Would you like to keep the existing should if we did that, or drop the existing should?
I would prefer to drop it.
Okay, that's clear. Thanks. Is Maria next?
Yes.
Okay.
So I personally would be fine with any number here, but I think I would like to keep the normative should, and I think for the normative part, it should be one per round trip time, because that's kind of the mechanical lower limit that you really need to kind of keep everything working. So I think that is actually a good recommendation, even, or like that is kind of this lower barrier, while you could easily recommend a higher value. I think that's like still the minimum we should keep in the draft. And also I noticed, and I developed a slightly more strongly opinion about this than before the meeting, because I noticed in TC working group that we actually, and in TCPM, that we actually have other documents who also use kind of this barrier. I'm not sure if they use normative language, but that's kind of very often the assumption.
Yes, there's a very similar document in TCPM, and I think they are currently borrowing our text. So whatever we decide here may very well end up kind of being reapplied there, just for people's context. Kazuo.
Right, Kazuho. So my comment on the issue was that I don't have a strong opinion regarding if we should keep the should or weaken the recommendation in some sense. But my point was that probably the lowest frequency that we know to work fine is like 4, for example. And I can come up with bad cases where it's like 1 per RTD. So I think my preference would be, if we have to provide some kind of recommendation or a weak recommendation, I'd say that if just referring to a safe value would be a better idea rather than discussing if 1 would be adequate or not.
Okay. Does anyone else have any comments? Is there anyone with you online? Corey.
So I'm
We cannot hear you. Oh,
Can you hear me yet?
yes,
Good.
sorry.
Right. Okay. So I think the lowest number that works reliably with any return path, which has lots of traffic and potential loss on the return, is actually 2 rather than 1. If you lose 1, the window stalls. If you set 1, then any burst of acts will be extended by any burst of data will be extended by, I'm tired, wrong time of day. If the return channel has a burst of data, then the acts will get delayed, and you'll end up with the same issue that we had in slow start growing the window, as you're using continually a data stream. So having 1 is actually quite fragile to loss, and we haven't done that in IETF protocols in general. Make the forward performance directly related to the loss or timing changes on the return path. So I think this is quite a big change in the direction of a transport protocol. And I would love to see stability analysis if we're going to go for 1. I think it absolutely should be normative language to have something that's stable. I don't think we should be building a protocol that's broken. In a data center, well, okay, maybe you could say, if you're in a data center, do something different. Maybe the data center case is so different because the RTT is so small, you don't actually care about stalling for an RTT. I don't know. I don't know about data centers. I do know about internet, and I worry about this. What you do about 3 and 4, well, good to talk about it, but it's a recommendation of what works in practice if you do real tests. So it's just recommendation, I guess, as in lowercase recommendation. But I would motivate using normative language, and I would say that 2 is actually the place where things are actually stable to act loss.
Thanks, Rory. Are you? Can't see the queue.
Yeah, I wanted to add something. So about the data center case, I think this is why we have a should here, right? I think we should give a recommendation for the internet-wide case, but it's not a must because there might be other cases. So this is like not something I'm buying. To reply to Gory, I'm also not fully buying this part about losing an egg, because it's not like you will lose all your eggs ever, right? It might happen occasionally, and then then it doesn't work perfectly this one round trip time. But I don't think that's a big argument for it.
So I'm going to agree with, speaking as an individual, I'm actually going to agree with Miria on that second point. Like the transport's not going to break if we do this. Like, so I think we should be clear on that. It's not like if you don't act, every RTT quick just falls on its face and dies. The thing on the data center, yeah, it should cover the internet case, but I don't think that we should take that for granted in standards documents that we're only talking about things that run on what we know as the internet today. I think that's a fairly closed-minded view of what this document should be and what documents should be in general. So I would say that this document, at least I think philosophically, is more a mechanism. It should be less light. It should be light on recommendations, and recommendations could come in subsequent documents about how to use this frame for the internet or for data centers, et cetera, et cetera.
Thanks, Matt. Martin?
So, Martin Thompson, for all of you who are not following the chat, I made a comment in chat that sort of outlines what I think would be a nice thing to say here. I don't think we need recommendations because of the vastly varied deployments that are out there. I think there are some facts that we can put out there that are fairly well agreed among us, which is that if you send fewer racks, performance may degrade in terms of congestion control and loss recovery and things like that. Maybe not in terms of your CPU and the other side's CPU, but that's a thing. And we certainly know that sending fewer than one ACK per RTT can have serious consequences for performance. And even sending smaller numbers of ACKs per RTT can have some negative adverse effect on performance. And we can also say that if you have extremely low RTT and stable delay, you may be able to get away with fewer, but don't say anything more on that point.
I just wanted to add that the main reason why there's currently a should in the document is because there's a should in RFC 9000.
That might be an argument for removing it from this document under the thesis that we haven't been in the habit of repeating shoulds across documents, especially in this one. We had a number of duplicative shoulds and musts, and we erred towards getting rid of them whenever possible. But personal comment.
Yeah, but we kind of like the whole point of this document is kind of saying you shouldn't apply the should in RFC 9000 anymore. So, but like, I mean,
that's okay for this particular behavior. I think. Well, I mean, we can just cite RFC 9000 for this text if that's what we'd like to do. But yeah. Okay.
I think that's it for the queue right now. I'm not that it was a little bit of a muddied conclusion there, but I think we can do some further discussion, perhaps on the list or something.
Okay. The takeaway I'm getting is RFC 9000 says this, so we probably don't want to weaken it, even if it's kind of maybe unnecessary. And people definitely would like a little bit more discussion of practical use cases and potentially not quote unquote recommendations, but some guidance around what values to use, such as numbers like 4 that have shown to work well for internet congestion controllers with relatively large PDPs. That part? Thank you. That's all I have. Oh, except once we resolve this, what are we doing next?
So thanks, Ian. You forgot to say in your updates on the document that Myriad joined as an editor to help, and that's, I think.
Yes. Apologize to.
So thanks for doing that. I think we're making good progress now. There's this issue. One was opened just during this meeting by Kazuho about error codes. I think that one's probably a quick fix. From that point on, I think we're ready for working group last call. So some folks asked us about that during the London IETF, and we've drained all of the issue queues. So we'll be making the preparations to look out for that, and that's going to be a great opportunity for people to review and really take a deep dive into the doc and let the authors know what needs doing before we can go on and progress this draft. So great, thank you.
Yeah, I did want to reiterate, thank you very much, Myriad, for all of your help, as well as your motivation to move this draft forward at a much faster pace than it had been moving. So it would not be where it is today without you. Thank you.
So next up on the agenda is me. I'll be presenting QLog in place of Robin because he's not in person and at an awful place. So I'm going to jump up to the big mic, and Matt's going to drive my slides. So yes, I'm not Robin. These slides are no fun. Next slide. Since IETF116, we've published one set of new drafts. We've got the 3 documents. There's been a small amount of consistency changes in those things. It's not as big as some of the other updates we've done in the past. This is mainly to do with something called the raw info type. What we have in a lot of events is the idea that you maybe don't know what it is necessarily, like a strong type, because QUIC's so extensible. You receive something, you know the rough shape of it, and then you can log like the raw error code that you received on the wire, but it's an extension type and you would have ignored it. So, and we support this throughout various places, but there was an inconsistency that's been tidied up. That's kind of a breaking change or whatever. So something to watch out for if you're tracking updates to your QLog implementations. So that's kind of the easy stuff. Something that was more kind of controversial, say, at the last meeting, and it was great to have the discussion in the room with people, is kind of the scope of QLog. It's been rumbling on for a while now, and people keep coming up with great new ideas and extensions for QUIC. Where do we draw this line of what we include in that document that just keeps expanding the scope and feature creep of one set of documents? We don't want to be doing this forever. We want to cut some stuff. So the decision we came to as a kind of an authorship group is that we just draw a line at the end of December last year, and we'll try and include everything in that. It's not too hard to include some events, but other things like multipath raise a whole new set of questions. So some question about whether each extension to QUIC should define its own QLog, or we define a QLog draft or whatever. Like, we don't want to DOS the system, and we're not looking just for big numbers of RFCs. Like, we don't want to keep doing lots and lots of busy work for basic things. So we'll solve that that problem in the future. But yeah, we have a clear scope of what we're trying to do now, and that's what we're working to. We've also requested an early sector review of the security and privacy considerations. While QLog is more of a format than a protocol or anything, Robin presented a lot of the security and privacy angles of things about logging data that might include sensitive or confidential things. And we have a general idea, and we think it looks okay, but now is a great opportunity for us to get way more input there and just to keep putting things in or to clarify stuff where possible. So that's in flight now. We're hoping to get something back, but again, please keep reviewing these things and adding stuff. And then we've continued working on many other open issues and PRs. Next slide. So I want to get into some of these issues because we've got way too many, but a lot of them are editorial and not that important. We need input on certain other things though, because they affect the interoperability of QLog. That's kind of future maintainability. And then there's some other things specific to the protocol that as a group of authors, we're not quite sure. So we want the group's feedback. This one is about versioning of QLog in the additional schema. So like I said, we have these 3 documents, the main schema, the QUIC schema, and the HTTP3 NQ-back schema. But to represent all of those things, we only have one version field, the QLog version in a QUIC log. And so the challenges for that is that these schema are not really tightly coupled. We do it as an editorial process, but at some point, we're probably going to expect them to need to iterate independently as we address feedback kind of coming up to the end run. And adding a weird artificial tight coupling is a bit annoying. We could manage a bit, it's not even for us now. We want and we expect new additional schema documents to be coming in the future around the extensions aspect I just talked about before. And then like this kind of thing that just because an endpoint could log an event doesn't mean it will. What does a schema, what does a QLog version mean? So effectively what we want to be able to do is just effectively have an includes at the top of the QLog that gives you a clear indication what documents the QLog events are based upon, so that a parser has a decent chance of parsing them and dealing with them properly. Next slide, please. So there's a proposal up in PR284 of adding an additional schema set, just an array of schemas based on some unique label. We don't want to have to own that in the sense that we don't want to have to create a registry for these things. We don't want to go full URL either, like XML schema. That seems a bit annoying as well. So the current proposal is just to punt the labeling uniqueness off to something like the data tracker or the RFC editor. So here, for example, the additional schemas including the quick QLog quick events and the quick QLog quick H3 events. I might have mistyped that, I can't remember. But yeah, the idea is we have the version which explains what the main schema is, the structure of the file itself, and some of the base events that form up every QLog. And then on top of that, the additional things. Yeah, like, does anyone have any opinion? Does this just sound like a smart thing to do? I'm seeing one thumb up at the back, and I'll take that. So we'll hammer out some of the finer details on that PR, but it's probably going to be ready to go, and we'll merge that one. Okay, cool. Next one. Naming things, it's really hard. Maybe I should put that one first because it's one of the hardest questions of stuff. Because of the way QLog evolves, it's got a Q in there. You could say it's for quick, but it's not. The main schema is effectively agnostic to other protocols that could be running on the top. We're not defining that now. We're not going to expand the scope of this or anything. But when we try and, like I just said, look at additional schema, there might be people who want to take a QLog ecosystem and then say, oh, what would be cool is like to apply what we've done here for HB3 and this analysis pipeline that we have and kind of retrofit it back to HB2 because some of the problems there are similar. Or we developed some analysis tooling for congestion control and having some of the TCP information might be similar. And so that's fine, but the problem we have is that the categories of events, so the categories that events belong to are kind of a bit too broad. And then they spill into the events themselves. So what we have is these criteria, the connectivity category, the transport, the security, the recovery, the HB, and the QPAC. Next slide, please. And so the proposal is not to rename all of them, because actually some of them are broad and that's good, but when they're too broad, that's bad. So the proposal there is just to rename the HTTP category to H3. And we have things like HTTP frame parsed actually becomes H3 frame parsed. And then when we want to do H2 in the future, if we do, then it becomes much clearer that H2 frame pars and H3 frame pars are different. Even though they're very similar, there's like subtle differences that can creep in, and it's kind of annoying. I noticed this most when I was trying to do some netlog parsing, and things like window updates, window management are just that different enough you can't come up with something generic. So that's my proposal there. And in the discussion, Robin said, well, if we're going to rename that, we might as well rename transport at the same time. So we should move transport to be quick, because all of the events in there are completely quick specific. Leave the other names alone. This is a trivial fix to do. There's editorial work we have to do in the docs, but beyond that, it's going to be a breaking change and might be disruptive for implementations, but now seems like the right time to do this. So this is the direction we'll take it unless we hear any kind of pushback. I'm not saying anything in the room, but if there's any pushback, go on the list and or the GitHub, and we will solicit that. Okay, cheers. Next slide. Multipath support. We have a current plan to add an opaque path ID top level field that just can be logged in each event. It's nice and flexible, but we have questions about whether that's enough. And we're just wondering, do we have a clearer view on what the needs of those events are as people are progressing the multipath draft? See, Christian's just jumped in the queue. I could take this off actually. He's been commenting on this issue, which has been helpful. I don't know if maybe the interop stuff we've talked about at the hackathon would help us actually understand as a community if there's certain other things we need to add. But Christian, do you want to jump in?
Yeah, that's my general feedback there, is that we we should probably wait a little bit before we try to commit, because we already waited 2 years since that issue was open, so we can wait a little bit more. And also, if you follow the previous debate, we just make sure that we have this notion of loose pass ID, which is tied to the connection IDs. And so whatever we do in the model should reflect that instead of theoretical IDs we had 2 years ago. So I would say, yeah, let's wait a bit.
Okay, I think that's a clear enough signal for me, but yeah, I'll confer with my co-authors as well. Miria?
I think I agree. We need a little bit more experience, but I mean, I just want to say we kind of obsoleted the pass ID here, so you probably don't want to introduce it again. But the problem we still need to solve with QLog is that if you only use a connection ID, it's really hard to map kind of the events that belong together on both sides. So I think that's a problem we need to think about, how to do that in an easy way.
All right, yep, thank you, I agree.
The other issue is the matching of events. I mean, if you have things that are, we are going to have multiple number spaces. And if you try to do multiple number spaces with the current version of QLog, your graphs look like shit. So you really want to have this notion of multiple number space put inside the QLog model so that people know how to do references, that an event that says an ACK of packet number 25, it's within a number space, it's not for the whole connection and things like that. That's the kind of work we have to do.
Yeah, and just to remind people, you know, we have various other fields in QLog that aren't like literally stuff that's sent on the wire. They're kind of additional information. So that's possibly some of the way we could model this. But yeah, we'll take an action to just go away and keep noodling on this. I don't think we need an immediate thing, but something we want to provide accommodation for without going full multipath, because no one wants to do that. Joking. Next slide, please. QPAC, right, this is great. We've been kind of, oh, Robin, do you want to respond to the multipath thing?
Yeah, if you can hear me.
Yep.
Just a quick one. Like, we decided the scope would be everything published in an RFC or IANA at the end of 2022. Multipod is clearly not part of that. And so this would be the only exception that we currently make to our defined scope to do anything in multipod. So keeping back QLog for multipod is a bit weird to me from that perspective. I would prefer to just say we don't do anything around multipod in the current QLog draft and do it as a separate document later if needed, but that's of course my opinion.
I'll jump in with my response. Of my understanding is that the request wasn't that we block the QLog draft on that, but that we just keep that issue open a while until we get a little bit of more deployment experience to figure out the simple thing we can add, and we don't need to pick the exact shape of that thing yet. But yeah,
and I agree with that. And if we can do that by the time we want to finish QLog, that's fine. But if it would go over that, then I don't think it should be a blocker.
Okay.
Yeah, and I think that this is the comment I made also last time. So it shouldn't block the document, and it should go in a separate document. But like, we have to be sure that we have a good way to get it in there. Like, if we define QLog and then later on figure out like, oh, we did this wrong, or we can't like easily add something that is needed for multiparse, that would be a problem.
Okay, I agree with both of you. We'll find a way. But QPAC, yeah, QPAC has been the unloved child, I think, of some of the QLog stuff. Well, not just QLog, Alan, but you know. But it's we took a very I don't know what the word is, like looking at the spec and saying, oh well, this is all the stuff in the spec. You just create an event for each thing, and then you go, great, woohoo. That works pretty well for QUIC and HTTP3 actually. The main events you want to care about are packets arriving and frames and this and that. But QPAC, it's potentially less interesting. It's not about the functionality, but it's more about the behavior. So yeah, like we said, we've got these current events, but Luca and Alan have been discussing about ways like what's actually useful for implementers, people who are trying to tune their QPAC or like investigate a bug that they might have, trying to do other stuff. So the proposal here that's been written up is that we have higher level events for conditions in the encoder, the decoder, or at the connection level. So we go to the next slide. We have this set of encoder events that you've included a field section block, or you had a blocked insertion and you voided reference, blah, 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 you know, various things like that. We have decoder events that are different too. And then maybe at the end of this, the connection, you have some global stats for both the encoder and the decoder. You've got to remember, you know, QPAC's running in both directions independently, but coupled, if that's the kind of view people agree with. But that's a proposal. I don't think it's a PR. I think that was just written up into the issue. So I think what personally I'd like to see is that written up as the PR. So we can actually see the, you know, the actual data types and stuff that we're suggesting. But if the overall shape of this looks okay to people and there's no major objections, we don't want to waste time doing the harder work if people think this is just not the right approach. Not seeing anything. The question I did have is whether this is in addition to the existing QPAC events we have or a replacement for. So I don't know if Luca or Alan can respond to that one.
Alan Frindell, intense QPAC enthusiast. I think it was viewing it more as a replacement than, and if you look at for folks who love QPAC as I do, or have a QPAC implementation, take a look and see what's there. Certainly having like the lowest level of events is sort of like the QLog is sort of replacing TCP dump, right? So you sometimes want to see like every single byte that went there and recreate that. The header fields often have sensitive information and stuff. So maybe that's not what you want. And the reason you're looking at this data is so that you can tune it, like you're saying. So yeah, that's one. And I guess the other question I have is, I mean, I'm sort of interested in actually implementing these events in our implementation because we've recently seen that QPAC dynamic table actually does make a difference, and tuning it is interesting. But I guess I'm curious if there are other people who have QPAC, if they would. Are we just writing this down and everyone's like, cool, like that's in the QLog spec, but nobody implements it, or is it something that's going to happen?
I'd be more interested in these high-level events, but also having the option to do the lower layer ones too. Like a lot of stuff in QLog is like totally optional, but what you feel comfortable with, especially with the privacy and security considerations. Like you're right, some of this could potentially be abstract enough that it's okay, whereas the other stuff isn't. But yeah, I think keeping both is good. I would ask for the PR that would propose these properly to also update the security considerations if there's anything to think about. So thank you very much for that. Yeah, we can move on, I think. Clocks, this is my issue. A recap that like every event in the QLog trace has a timestamp, and the value of that timestamp depends on the format that the log declared things have. So generally, the Unix timestamps are kind of implied, but they're not mandatory. That's what the spec allows. Potentially, not everyone wants to or can even use Unix time. For example, if you're on Windows and you wanted to use Windows epoch, the spec would allow you to. Or if you have like a monotonic clock as your base clock and you're calculating a relative time or delta time based on that thing, you have this incrementing value in your logs, but it doesn't actually relate back to anything in the physical space. This has come up in the quiche implementation because researchers want to take a look at a QLog and try and link that back to some time, like a wall clock time that they can then correlate to other stuff that's happening in the system, which sounds like something that's good, but there's the whole problem with clocks and drift and mismatches and all these kinds of stuff. I don't think we want to try and solve that general problem, but what we need to do is fix QLog just to make it a lot clearer that if you have just a number that's a delta, we need to state what that delta is based on. We can't assume this information. So this simple proposal right now is that we have a field that can carry an explicit epoch date in a format, suggested ISO 8601. Could be something different, but that seems sensible. And then possibly a special opaque tag or something to indicate scenarios where it's a clock monotonic situation where the system booted up and just picked something as its starting base, and then from that point on, you can query it and get some number back. I see Victor jumped in the queue.
Victor Asili of Google. So one thing is I'm not entirely clear for me from this issue. Do you intend to use ISO 8601 for every timestamp, or do you define it once and then compute timestamps relative to that timestamp?
It would be once at the top of the file, or once somewhere, to basically provide that anchor for all of these other events, which are smaller encoded things. So, for example, we have absolute value as a potential format, which is the number of seconds since the Unix epoch. So it's kind of absolute, but it's not really. It's a bit of a misnomer in my mind. I'm sure Robin disagrees with me there, but yeah.
Wait, so do you allow changing the format of every timestamp, or do you is this for the format of the timestamp at the top?
It's the format of the timestamp on every event. We only allow that format to be declared once for each QLog thing.
One thing you might consider, and this is something we had a lot of success, is at least for our logging, we always put one timestamp in the beginning, and all of our timestamps are always relative to that timestamp. And since we use variants, it compresses extremely well. And it also generally means that you have to solve the anchor problem only once.
Okay, yeah, that's good feedback. I might try and have another discussion with you. To be clear, QLog is, potentially the serialization format's open, but we can't serialize variant to the wire. That's well, you can, but I don't know. Anyway, how's the key? Andrew
McGregor, +1 to the relatives timestamp suggestion. That's a great idea. There's precedent on how to represent times. Do use that, because just opaque for something like clock monotonic, that doesn't begin to cover all the possibilities for what you might get in there. And even 8601, okay, but is it in TAI, UTC, Google's thing? What time base was it referenced to? Yeah, we have precedent for this. Please use it rather than just go off and do something random.
I'd obviously like to. If you could provide some references to that, that would be greatly appreciated. Martin?
Yeah, I like the idea of having a sort of, here's where we started, and here's the epoch for the subsequent records. Because we're using something like monotonic in our implementation, the documentation always says, well, it might drift a little bit over time, and it's not exactly 1 nanosecond between each one of the markers that are in there. You might find that this is not good for timekeeping, and I think this is to Andrew's point. It would be nice if we could periodically drop an update to the epoch in the sequence of events, particularly when your machine comes back from sleep, or there's been something going on that might be relevant in terms of getting a wall clock time. And that may be the simplest sort of way that we can do it. But if Andrew's got some better references for us, then I'd use his.
Okay, I think I've hit Cunningham's law here by posting the wrong answer and getting things. But this is to be clear, the clock stuff has been something that I've been kind of noodling on for about a year or so. So this is useful in the broader context, and I'm willing to put more work and cycles into that. So that's good. Thank you. Kind of out of time. I don't know how many more slides we have. ECN. Is this the last one? Okay. How and where to log in ECN markings. We have different layers of events, the datagram, like the UDP datagram, not the datagram room, but yeah, that all quick packet events. Right now, we're very basic. It's just the markings as well, nothing to do with probing or anything like that. And we have these names or bit values depending on the precise event. And I think, you know, the question is should ECN probing be covered at all? That's tracked in a separate issue, but this one, like, is it okay with what we're proposing as the solution? I don't know if anyone's looked at it. Robin, please dive in. I don't know much about ECN.
Yeah.
In the interest of time, Robin, in the interest of time, keep it brief. And yeah.
Yes. One of the things I forgot to mention on the slide here is one of my main questions was there. How do we deal with L4S? I don't have enough context on that, but I know they use the same or something. Is that something that QLog should reflect or not? And how do we reflect it? Is a broader issue. So I would like people who have knowledge about the L4S things going on to comment on this. That's basically what we want to say.
Yeah, I think so. I think probably the best thing here is to follow up with the relevant people. And okay, very, very quickly.
Nothing special about L4S. It's just using the ETC1 code point and you're covered. There's
Yeah, you could conceivably have other L4S events, but that's squarely out of scope. But anyway, so ECN enthusiasts, ECN enthusiasts, I think should follow up with the authors, and that would be good to have that feedback incorporated here.
Are we done?
Yeah.
Great. Thank you for your time.
Martin, you're up. Martin Seaman.
Your turn. Sorry.
We're a little bit over, that's not bad. I have my slide. Yeah. You do it. No, I'll let you do it. I've been doing it. I do it on your screen. Go.
Okay, resetting and closing streams. Let's do
Closer to the
something
mic,
basic.
or raise the mic.
Next slide. Next slide. Okay, there's two problems that we could solve. There's one problem that we definitely need to solve because web transport is relying on that, and the web transport working group has asked the QUIC working group to present a solution so they can build on top of it. So the problem is when you have a QUIC stream and you reset that QUIC stream, there's no guarantee whatsoever about what the application on the other side will have received from that stream. It could be that that the application has received nothing from that stream at all and is just getting notified the stream has been reset, which leads to the interesting problem in web transport that you don't know if this is an HTTP3 stream or if this is a web transport stream, and if so, which session it belongs to. So it would be really nice if there was a way to say, like, okay, the stream has been reset, but it belonged to this or that session. And there's a second problem, and we actually discussed this during our work on the QUIC RFC. And I've linked the issue here. So let's say you are a relaying proxy, and you're just passing through bytes from an upstream server to a client, and the upstream server has given you like a really large content length. You've already sent that to the client, and then at some point the upstream server dies. Now, what do you do as a proxy? Like you need to somehow convey that error to the client. So you'll probably send a stream reset, but then there are cases where it's potentially not desired to lose all the bytes that the server, that the upstream server sent before it died. So we currently don't have a good solution for that. Next slide.
So there's two proposals around basically. One is the draft, which is currently named reliable stream resets, that I presented at the last IETF meeting, and then there's a pull request to that draft, which basically completely rewrites it into a completely different proposal. And I'm calling it the Victor proposal here because he's the one who authored that pull request. So the basic idea is that you add basically a payload field to the reset stream frame, which is a variable length, but since this is a quick frame, it has to fit into a quick packet. So the payload is effectively limited to approximately one MTU. This is pretty flexible in the sense that the payload doesn't need to correspond to anything that was previously sent on the stream. It could be something completely different that you put into that payload. So it's in a sense a kind of miniature stream that you attach to like an actual quick stream. So this obviously requires changing the API of your quick stack, and depending on how vertically integrated your quick stack is, you might or might not care about this very much. But there needs to be some method for you to provide that payload on the sender side, and then on the receiver side, there needs to be some method to get this payload from the quick stack. And as I've mentioned before, like this, since this is limited to one MTU, we cannot solve the relaying use case. Next slide. So now coming to my draft without the PR, and as I mentioned before, it's currently called Reliable Reset Stream, and in a lot of discussions that we had in the last week on the meeting here, we realized that this is probably not the best name. I chose the name because, well, on the wire it pretty much looks like a reset stream frame. On the left side you have what's in the RFC 9000, and on the right side it's what's in the draft, and there's like this one additional field. So was kind of obvious to call it something with reset stream, but as I will explain now, when you implement it, it doesn't really make sense to think of it as a reset stream frame. Next slide. So let's look at the sender side, and at the one situation where it kind of is like a reset stream. So let's say you have the stream, you already sent like 100 bytes, and these 100 bytes you really need to get through, and then you send an additional 100 bytes, and now the application is saying like, nope, reset the stream. So what do you do now? You send this frame with a reliable size of 100 and a final size of 200, indicating to the flow controller that there only was like 200 bytes on the stream and nothing else will be sent. So everything's fine here. Next slide. But now there's a different case where, let's say you also need to get these 100 bytes through, but you've only sent 30 so far. And this might be because you might not even have 100 bytes of flow control window on the stream. It could be that the peer only allows you to send 50 bytes, and you need to send these 50 bytes before you get credit to send the other 50 bytes. So at this point, you are not allowed to send a frame that says final size 100. That would be a flow control violation. So what do you do now? So this is where the notion of this is a reset stream frame breaks down. So when you think about it as a kind of fin bit on the stream, things get a lot easier. So think of it like this is not a stream reset, but I'm just writing 100 bytes to the stream, and then I'm closing the stream as I would normally, and send a stream frame with a fin bit. So what would you do when you can't send out these 100 bytes? Well, you would send out the 50 bytes that you have flow control credit for, and then you would wait for more flow control credit, and then send the remaining 50 bytes with the fin bit then. So you would wait until you've sent all the 100 bytes before you act on that fin bit. So now this new frame that we have is more like a different kind of fin bit. Next slide. So what does that mean for the API on the sending side? So this is like pseudo Python code here. I assume you have some kind of write method on the stream that the application calls repeatedly to send out bytes. And one way to implement this is to add some kind of commit method, which when you call it says like, okay, the bytes I've written so far are the bytes I want to be delivered reliably if the stream is reset, and everything that I'm now calling write for in the future, this is the thing that gets lost. So you need this one additional method, and obviously there are other ways to implement this. Next slide. So let's have a look at the receiver side. What do I do? I accepted the stream. I've read a few bytes from the stream, and now I receive this frame that tells me there's a reliable size with some offset that I haven't received yet. What do I do? Now it makes sense to again think of this as a fin bit. Let's say you receive a stream, and you receive the stream frame that has the fin bit, but you haven't received all the data before, like there might have been packet reordering on the wire. Now you don't do anything with it, right? You just wait until the application has read all the data up to the point where the fin is, and then you do something with the fin. Like you tell the application the stream is now closed. And you do this exactly the same thing here. You would wait until the application has read up to the reliable size, and then you would tell the application, oh, by the way, this stream has been reset instead of fit. So the implementation gets really easy if you think about it in that way. Next slide. So what do you need to do on the receiving side? You don't need to change any API, and this is something I really like because for any application building on top of QUIC with this extension, they don't even need to know that this is happening. Like they just read from the stream, they get, like, for example, their web transport session ID, and then at some later point, they get told like, oh, by the way, the stream was reset. No API changes needed. Next slide. So if we don't call it reliable reset stream, what should we call it? Don't have any strong opinions here. I've heard some people advocate for stream close, but I'm happy to bike chat this, and I'm sure we can come up with some name, or maybe not. Next slide. So this is to give you an idea what it takes to implement this. I've implemented this in QuickGo, and Kazuha has implemented this in Quickly. For me, it was around 80 lines of code for the stream state machine changes, and in Quickly it was about 50 lines of code. And I have like this end-to-end test where randomly reset streams and drop packets on the wire and just make sure that everything gets through as it should and works. And QuickGo and Quickly also have achieved interrupt during the hackathon, so it seems to work. Next slide. So where do we go from here? Should we adopt one of those proposals?
So some slight guidance with chair hat on here. I think the focus here should be adoption of whether the existing draft, not saying that is going to be the final solution, but is spiritually the solution rather than the going with the attaching a payload to a reset, which would probably have to require a different draft to be adopted.
Just to add quickly, like we take this as a dependency for other groups in the working groups in the IETF who would like or who need this feature to be able to continue their development, and that's what we've agreed to since IETF 115 in discussion with those other chairs. So please keep that in mind too. Thanks.
Mike Bishop, as I've said at previous times you presented this, the overall problem is one that is good to solve. I like this approach. Not wild about closed stream, but we can paint the bike shade whatever color we want, mostly because that is the specific term we use in our FC 9000 for sending a fin, closing the stream.
Christian.
I have one concern there is that the one problem I see happening a lot is people dealing with the rest condition between the reset and the fin. As in, an application has sent a stream, we say a short message on the stream, and then believes that it has not been received at the other end yet and say, hey, I want to cancel that, and they reset and say, yeah, forget about this thing I started. It's a different issue that you have, Martin, but I wonder whether you have the same issue of rest condition between the initial fin and the short fin. And by the way, short fin might be a good name.
Alan Frindell. I'll try to keep this quick. I have a bunch of thoughts about it. So when we first were developing Quick, we said we're not developing partial reliability features, but we were kind of lying because reset stream is a partial reliability feature of Quick. It's basically saying the stream is unreliable starting at offset 0. And so you can think of this as an extension, or you can do it the other way, where this is taking a stream and dividing it into a reliable half and an unreliable half at the offset. And reset stream is a specialization where that offset is 0. So I think this is easy and it solves a problem that we have right now, but maybe we haven't thought holistically about, is this part of what this group wants to provide as a partial reliability surface for Quick? If we do add it as a partial reliability surface, I think we need to make sure we also raise that surface in WebTransport, right? The WebTransport API needs to also have this capability because, at least in my opinion, I view WebTransport as an extension, taking everything in the Quick API surface and making it available in the web. Hold on, I have a couple other things that I'm not remembering. We talked also about the ability to send this without an error code, and you didn't mention it here, so I won't spend too long on it, but I think that's super dangerous for reasons, but we can save them for later. I'll jump out of the queue. There's a lot of people.
Maybe I can respond quickly. Yeah, I've avoided calling this partial reliability because when people, there are different notions of partial reliability, right? There's the most general case of like, I have this stream and like this part is reliable and this part is reliable and this part is reliable, but everything in between isn't. And I didn't want to open up this discussion because I think things get a lot more complicated. And this is obviously more than we need for WebTransport and more than we need for the relaying case. Yeah, but I'm happy to concede that this is a step towards full partial reliability.
David Skenazy, bike shed enthusiast. So speaking with my WebTransport chair hat on, WebTransport has been taking quite a while. I'm starting to wonder if the W3C is going to publish their API before we can publish the transport underneath it. And let's not have a repeat of WebRTC, please. This is critical to WebTransport. We can't ship without it. So I would say I'm hearing a lot of good questions, like what to do when there's also a fin. What should we have an error code? These sound like great questions to answer in the working group. So my personal opinion is, yeah, please adopt this. To everyone, if you have questions like this, please save them for once it's adopted and let us know if you think we should adopt to like help move this forward and unblock WebTransport. And on the question of the name, I could not care less. Make it so.
Alessandro Ghedini, Cloudflare. So it seems there's a problem to solve, and this is a reasonable solution. It's great to see that there's already implementations of this. So yeah, we should definitely adopt this. And then we can then spend the next, I don't know, 5 years deciding what to call it.
Kazuhoku, I agree that we should adopt this. I just want to say that for the relaying use case, during the quick V1 discussion, we saw at least 2 implementers interested in having this kind of fix.
Victor Vasiliev, for naming, the way I think of it is it's reset stream at, as in you reset it at certain offset. That's the easiest way for me to understand it. I'm personally fine with either approach, provided that they work, and it sounds like what we have in the draft works. I think that's it for me.
Yes, adopt. I like this better than the payload option because it seems more general, whereas the payload option has grid limitations on it that might cause it to come back here. Do you think we need a equivalent for stop sending? Please send me the first 50 bytes of this stream, but don't bother with the rest of it.
Let's not talk about that right now. It's a good question, though, Martin. Okay, so I think we're in a position where we're going to make an adoption poll thingy here right now, just to confirm what we're hearing at the mic. That it sounds like we're supportive of adoption, but let's run a quick poll. Basically, should we adopt it without caring about the name?
So, yeah, please raise your hand if you're in favor of adoption.
You can hum if you want to, just for old time's sake, but we're gonna ignore it. Okay, yeah, that's good enough. I think we will follow up and make an adoption call on the list. Thank you, everyone, for participating in that discussion.
Just for the record, the last count I saw on the screen was 38 raised hands to 0 do not raised hands, which is a pretty clear signal. Marcin, would you like to come up? We did have more time for Marcin, unfortunately. Come on up. Unfortunately, we overran on that, but we got the answer that we needed. So I appreciate your patience there. Yep, we'll share the slides now. But yeah, if you have any questions on this, come and continue the discussion with us, I think. Go.
Okay. Yeah. Hi, guys. I'm Marcin. I'm a PhD student from Freie Universität Berlin, and this is joint work with Jonas, Matthias, Pujan, and Thomas. Next slide, please. So, yeah, all this is based on a research paper that I actually also presented yesterday at MapRG, but I will not talk about the measurement setup and our methodology today. I just want to talk about the quick challenges that we identified. And basically the purpose today of this talk is to get feedback from the quick experts here about the challenges and to discuss different options. So next slide, please. The first challenge that we saw is that large TLS data triggers multiple RTTs during the quick handshake. Next slide, please. So what I mean by that is, I think you're familiar with the quick handshake process. Basically, the client sends an initial message. The server then is restricted to 3 times the bytes that it received from the client. And this is basically an anti-amplification mechanism. And then the client acknowledges this data. And only then if there's data left, only then the server is allowed to send the rest of the certificates and TLS data. And this is what we call a multi-RTT handshake. Next slide, please. And unfortunately, based on our measurements of around 250,000 quick domains, we saw that around 38% of quick domains actually exhibit a multi-RTT handshake. So the design goal of one RTT in the wild has not really been met. Next slide, please. So just to give you a quick overview, we looked at the reasons why these multi-RTT handshakes happen, why we have a lot of TLS data. And one of the reasons is actually that we observe long certificate chains, and especially non-leaf certificates are quite large. So in this plot, you, for example, see that the intermediate node certificates, which are gray, for example, for Cloudflare are around 1,000 bytes, but then you have a longer chain from Let's Encrypt, and they quickly add up. So we have certificate chains of around 2,000, 3,000 bytes.
David's got a clarifying question quickly.
Yeah.
Hi, David Skenazi. No, I can't say certificate enthusiast. I just can't. When you, in your previous slide, when you measured, and well, this measurement, which is by percentage, is it percentage of websites that you hit from one client?
Yes.
Okay, and did you consider that when you hit those websites with a second connection and you have, did you measure whether you have the address validation token to solve the amplification factor?
So for each connection, we basically completely triggered a new quick connection. That's what we did.
But from scratch without
Yes.
a source address validation
Yes.
token. Okay, thank you.
Okay, can continue. Next slide, please. So with a lot of TLS data, and we checked whether future quick extensions will actually make the situation even worse. And I looked at three drafts. So there's, for example, a multi-path draft, which currently set up one single connection. So we have the quick handshake and then adds multiple paths. But these paths do not create a new quick connection. So this is basically the same challenge. The situation will not be worse. Then there's the version negotiation draft currently for the compatible versions. Also, this is the same situation. Basically, it only prevents the version negotiate packet before, but afterwards we have the normal handshake process. So same challenge. And in the end, so we're trying to make the internet quantum proof in the future. And there are different approaches to this. But for example, if we look at the hybrid design, what I saw there is that we mix or use both secrets, the conventional and post-quantum secure ones, and this adds data. So there was an AWS implementation, for example, that used around 800 bytes more. So for this case, the situation would be even worse. Next slide, please.
We have some people in the queue. I think they have
Okay,
clarifying
I already
questions.
triggered so many questions. Okay.
So,
It's my understanding that post-quantum cryptography in the TLS handshake would also make the client hello so large that it doesn't fit into one packet. So you would need to send two initial packets from the client side, which would actually solve the problem.
Okay.
Okay. We'll move on. Yeah.
All right, so basically this is my first observation here. QUIC was designed for low latency, but we observed a lot of multi-RTT due to cert sizes. And two questions I had here, for example, is should we encourage more TLS certificate compression? Because we saw a lot of server implementation supporting this, but clients actually struggle. And another question would be, do we need something like a best given practices for TLS and QUIC so that we explain how setups should be configured to reach the one RTT? Yeah, next slide, please. So the second thing that we observed was that in case of incomplete handshakes, actually there is no efficient recent strategy. And what I mean by that, I will show in the next slide, please. So basically, fine. We use a client that only sent a single packet, the initial message, and then the server responds and our client did not react anymore. And then we observed how the server behaves. And what we saw is that several implementations actually keep on sending the initial and handshake messages. And by doing so, they did not even respect the anti-amplification limit. So next slide, please. and even next slide maybe. And this is just an example, but for example, we scanned the MetaPOP, so we analyzed their implementation there. And again, these retransmissions should adhere to the 3x limit, but what we saw, they did not, and around half of the handshakes were around 5x, and another half around 20x. We also saw 30x. We rescanned this 2 months later, and the situation improved. Next slide, please. But it was still around 5x. So it seems like we still are above the anti-amplification limit. Next slide, please. So to conclude the second observations, we saw that resends easily contribute to reaching the amplification limit simply because we resend the bulks of large TLS data. So my question would be here, do we need maybe some kind of another strategy for incomplete handshakes until the client is verified? So maybe the server could resend data once if it fits into the anti-amplification limit, and then change to another mode where he maybe tries to probe the client to verify the client with small packets. So for example, ping frames or something like that.
We have a couple of people in the queue. Do you want to respond? We're over time, but if you want to say something, say it very quickly.
So the value of 3 was chosen basically completely arbitrarily when we wrote the specification. Could have been 2, could have been 3, could have been 4, could have been 5. I don't really care. So as long as there's some limit that's not like 50 or 100, any bug report that's like, oh, your implementation does 4x and the RSC says it's doing 3x, it's like, whatever.
We are over time. We're probably going to get cut off and booted out. So, Kazuhara, you've got something to say?
Thank you for the presentation. I just wanted to point out that we don't have a limit on the client side. It's IW, which is more like 10 packets. And there's a way of tricking clients to send packets to certain locations that you want to attack. So I don't think 3 is something we have to hold to.
Yeah, so I think if anyone interested, also check out Marcin's MapRG talk, which covered a lot of the same topics. And if you're interested in doing standards work in this area, feel free to publish drafts or also collaborate. And thank you, everyone, for attending the QUIC Working Group.
Thank you.
Thank you all watching. Sorry about that.
Yeah,
So like being on the as time permits buckets. Oh no, let me.
Does it let you do it now?